In this module, you will learn about different types of functions. Take a look at the diagram. It shows the graphical representation of the function f1 from a to b. On representing In this module, you will learn about different types of functions. Take a look at the diagram. It shows the graphical representation of the function f1 from a to b. On representing the given function in roster form, we obtain a set with 4 ordered pairs. Observe that different elements of set A have correspondence with different elements of set B. That means the images of different elements of set A under F1 are different. We can also say that no 2 ordered pairs have the same second coordinates. Now, take a look at this diagram. In this case also, the images of the distinct elements of set A under F2 are distinct, or no 2 ordered pairs have the same second coordinate. Such types of functions are known as 1-1 functions. Let us define it mathematically now. A function f from a to b is said to be 1-1 if the images of the distinct elements of a under f are distinct. That is, for every x1 and x2 in the domain of f, f of x1 is equal to f of x2 implies that x1 is equal to x2. Or, if f of x1 is not equal to f of x2, then x1 is not equal to x2. A 1-1 function is also known as an injective function, or simply an injection. Further, if a function is not 1-1, then it is known as many-1. For example, function f shown here is not 1-1 as 2 distinct elements, 3 and 4, of set A have the same image, -3 under f. Hence, function f is many-1. Look at functions f and g. To check the functions for injectivity, we consider any 2 different values in the domain of function f and check that their corresponding outputs are different. In the first case, different elements have different images. Therefore, the given function is 1-1. However, in the second case, the image of 9 and 23 is -4. It means that g of 9 and g of 23 is equal to -4. Hence, the function g is not 1-1. Moving forward, let's now show that the function f from R to R, defined by f of x is equal to 2x, is a 1-1 function. Let x1 and x2 be any 2 arbitrary elements from domain R of function f, such that f of x1 is equal to f of x2. Now, f of x is equal to 2x, so f of x1 is equal to f of x2 implies that 2x1 is equal to 2x2. This gives x1 is equal to x2. Hence, for any 2 arbitrary elements x1 and x2 in the domain of f, f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, function f from R to R is 1 to 1. This diagram shows the graph of the function f of x is equal to 2x. Given the graph of a function, you can check whether it is 1 to 1 or not with the help of a test known as the horizontal line test. To check the injectivity of the function f of x is equal to 2x, we draw a horizontal line such that it cuts the graph. This line cuts the graph only at one place. Such types of functions are known as 1-1 functions. In this graph also, the horizontal line is intersecting the graph at only one place. Hence, the function is 1-1. In cases where the line cuts the graph of a function at more than one place, the functions are not 1-1. This diagram shows the graph of a function that is not 1-1. Let's now discuss the onto function. Let's begin by considering a function f from a to b, which is shown here. From our previous knowledge, we can find the codomain and domain of the function. The codomain of function f is set B, with the elements 5, 6, and 7, and the range of the function is also the same set. It implies that the range of the function is equal to the codomain of the function. Such functions are known as onto functions. Mathematically, a function f from a set A to a set B is said to be onto if and only if for every element y of B there is an element x in A such that f of x is equal to y. This implies for every y in the codomain there exists at least one x in the domain. So we can say that the range of f is equal to the codomain of f. Hence, f is onto if and only if f of A is equal to B. The other name for an onto function is surjective function or simply surjection. The functions in which two elements are mapped to the same element are also onto, provided there exists a pre-image of every element in the codomain of f. For example, function f from A to B is onto. However, g is not an onto function since the element 4 in the codomain of g does not have any pre-image in the domain.